Alright guys, here, let's start right away. Did everybody grab a notepad when they came in?
No.
I believe so. Yes, no?
Maybe so.
Okay, hopefully you did. Here's the deal. Yo, let me talk please. So, Casper out here, Julie, you guys start the test. Yeah, I'm thinking. So, we are starting a new unit. Now please let me explain why we are starting a new unit. Alright, we are starting a new unit. That way, when it comes like finals time, so I worked it out on my calendar, we have like 7 days, or like a whole week, to actually review for our final. Plus, all we're doing today is review from Algebra 1. All we're doing tomorrow is a group work. So we're not doing any heavy, intensive stuff the next 2 days, but we're getting those 2 days then when we're studying for our final. Alright? So that's our rationale for starting a new unit. Is that okay? No. Okay. So, we're starting our last unit of the semester. It's called Solving Systems. You probably did one just like this in Algebra 1.
Yeah.
So, guys, so we're going to talk about systems that have 2 equations and 2 variables. We're going to talk about systems that have 3 equations and 3 variables.
Can we not?
Today, like I said, we're only doing a review from Algebra 1. So, we're reviewing how to solve a system by graphing, we're reviewing how to solve a system by equivalent forms, and by substitution. We have like 6 problems to do only. It should go really quickly. We should have time to see our test after that. Okay, and the homework tonight is 8 problems, one-sided. Okay, so, systems of equations. So, a system of equations is 2 or more equations with the same variables, right? Like I said, we'll do 2 equations, we'll do 3 equations. I don't think we're going to get any farther than that. We're not going to go to 4 and 5. This is not actually the fill in the blanks, it's just that one question. But I'm going to keep talking about it. So to solve a system of equations, it needs to find the values that satisfy all of your equations, right? It's not just going to satisfy 1 out of the 2 or 1 out of the 3. It's got to satisfy all of them at the same time. It's got to make them all true. So let's talk about if there's like 2 equations and 2 variables, your solution is going to be a combination of x and y values, right? It's going to be just 2 separate numbers. When we graph a combination of x and y values that satisfies a linear equation must be a point. It's got to be a point on both lines, right? Because if we have an equation, the only numbers that satisfy that equation are ones that are on the line. Well, if it's going to satisfy both of the equations, it's going to have to be on both lines, which means they're going to have to intersect. So when we're solving by graphing, we're going to look for where they intersect. Our point of intersection is actually where the answer is to our system. It's going to be pretty easy. And hopefully you remember part of that from Algebra 1. But our system, solution to a system is always going to be written as an ordered pair. So I don't think that's on there anywhere. Right? Like I said, these aren't the actual blanks you're supposed to be filling in right now. You're not filling in any blanks. I'm just talking. But I would maybe write on there somewhere that the solution to a system of linear equations is an ordered pair in some way. Because that's how we're going to write all of our answers, not just when we're graphing, but if we're doing equivalent forms, whether we're doing substitution, combination elimination, anything like that, we're going to write them as an ordered pair. If you don't write it as an ordered pair, it's probably going to get marked wrong. Okay? Alright, let's get to the fun stuff then. So, to solve a system of linear equations by graphing, here are your fill in the blanks. Graph both equations on the same axes or on the same coordinate plane. Right? Put them on the same graph. We just did that a little bit with inequalities where we put 2 lines on the same graph. That's all we're going to do. Now this says if the equation's in slope-intercept form, plot it using your y-intercept and your slope. If it's in standard form, plot it using the cover-up. But I'm not super picky about that. If you want it, instead of using the cover-up, change it to y equals mx plus b and graph it using slope and y-intercept, I'm perfectly okay with that. Okay? If you like the cover-up method, then use the cover-up method. Then, locate the point of intersection. I won't go too far, full, I promise. So, locate the point of intersection. I said, to be a solution in an equation, right, it's got to be on the line. So if I look and I see where a point is on both lines, that's got to be where they intersect, right? Well, then we're going to look for where they intersect, because that's going to be our answer. Lastly, you're going to write your solution as an ordered pair. Right? So it should be pretty simple. I do believe you've done this before. We had 2 examples to do for this part. For this part. We got some more. Do we all have the blanks filled in?
No.
Can I go on to the example?
No.
Jared, quit lying. So, first one. Our system consists of y equals 4x minus 1 and 3x plus y equals 6. If I want to graph this first equation, y equals 4x minus 1, what's my y-intercept? Negative 1, what's my slope?
4 over 1.
4 over 1, not 4x, just 4 over 1. So at negative 1, I'm putting a point. Up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. And then I'm going to draw a line through it. Remember, when we're drawing lines, you should be using straight edges. Now, like I said, it's your notes. I really don't care what you do in your notes. But on a test, you should use a straight edge. Okay? 3x plus y equals 6. I think most of you guys like to set it so it's y equals mx plus b, right?
Yeah.
So alright, so I'll do that. So if I'm going to do that here, I'm going to subtract 3x from both sides. I'm going to get y equals negative 3x plus 6. Well, my y-intercept then is going to be at positive 6. 1, 2, 3, 4, I gotta go up. 1, 2, 3, 4, 5, 6. And I'm going to go down 3 to the right 1. Down 3 to the right 1. And then I'm going to draw that line in. Well, where do the 2 lines intersect?
2, 1, 3. Wait.
Wait, you said 3 numbers there.
Oh, sorry, I can't read.
Okay, 1, 3, right?
3, not
Over 1, up 3. So I like to circle the point of intersection. Am I going to require you to do that? No.
I was counting.
You're going to have to. So look at the point of intersection, then you can write it as a coordinate pair. So 1, 3. Yes, if you forget parentheses around your coordinate pair, your order pair, it will get marked wrong. Please make sure you do that. Alright. Go ahead and try the second one. Go try the second one. Imagine how good that banana bread's going to taste.
I was actually planning on giving it to him anyways. I don't really want that.
That's kind of.
He just wanted the same.
Banana bread's better if there's chocolate chips in it. So.
If there's what?
It is what? Chocolate chips. That's
exactly what I said.
My mom, I will make you some for
Everybody
straight up
agreed with that.
Gotta make it by tonight though. That's just not happening.
That you would. Alright guys, let's go. Try the second one if you haven't already, please.
For New Year's.
Well, I also hope you for that.
I won't either. I'll be fun.
Well, because we're going to be on break still.
Well, like, or when we come back. I'm not here for like the first week.
It's really bad.
Yeah, no, wait.
Nice.
But I'm missing like funny stuff.
So once you've done your problem, you can check yours with mine. Hey, there's no rush. I'm not moving on anytime soon. So please make sure you're using straight edges so you don't like make wavy lines and you get the wrong intersection point.
Look at that line. It doesn't would you like to use my ID? I didn't use the right points.
Apparently not.
Oh, I did it positive, not negative. Ooh, I took problem.
Right, I did it.
Okay? How many got right?
Did I get it right?
Because I'll get right.
Getting one wrong is like fine.
What?
No, I was just like, I don't know.
No, I put it in incorrectly. They're changing it.
Oh my god. I thought I actually got 82 on it.
So what happened is both honors and writing both your tests yesterday. Your guys was at a 35, yours was at a 40. I actually put all yours in, did you either on 40? So I fixed the last out.
I thought I knew you were talking about it in Chem. So that's why I was like,
Yeah.
no way that you did.
I feel like I did so good.
Okay, so it is a 90.
Alright, hey, let's keep moving. Do we have any questions before I move on? We good? Back table, we good?
No.
Do we have any questions?
No. We good.
Alright, so, guys, quiet. So, we're going to learn two algebraic ways. So we just talked about graphing. Two algebraic ways. First one's called equivalent forms. So, equivalent forms. What you're going to do is you're going to write both equations in y equals mx plus b form. Now, 99% of the time, this will be done for you. Right? They'll both be equal to the same thing. Either it's y, it's x, it's z, whatever variable you're using. Now, when we give you a test, we are not going to tell you, hey, solve this using equivalent forms. Solve this using substitution. Now, we'll tell you when we want you to graph it, but the other ones we won't tell you when we want you to use them. So you need to kind of determine the difference between each different form, how we're solving them. Like in this case, they're both equal to the same variable. It's pretty easy to use equivalent forms then. Step 2. Set the expressions equal to each other. Right? If they both equal y, then these two pieces both need to be equal to each other. Right? So if I'm going to set them equal to each other, I'm going to go 4x plus 5 equals 3x minus 7. Step 3 then. Solve your resulting equation for x. So, with the equation you just made, your new equation, solve it for x. So we're going to subtract 3x. X plus 5 equals negative 7. Well, minus 5. X equals negative 12. Okay? We good so far?
Sure.
So first step, we'll set them equal to each other because they equal the same thing. Second step, solve for x. It's negative 12. Fourth step, take and substitute that value back into either of the original equations. Solve it for y. Elijah, do you want to use the top or the bottom equation?
Top.
Top, perfect. Doesn't matter what you're going to use, we'll use the top. So y equals 4x plus 5. Okay? Well, I know x is negative 12, so I'm going to plug in negative 12. Y equals 4 times negative 12 plus 5. Well, what's 4 times negative 12? Negative 48. Plus 5 would give me negative 43. So not only do I have what x equals, I have what y equals now.
Whoa.
And last step here, write your solution as an ordered pair. Right? I just talked about that before. Our solutions need to be written as an ordered pair, even if we're not graphing. So if you write x equals negative 12, y equals negative 43 on the test, marked wrong. Write it as an ordered pair. And then your last step, which, I mean, I'm not going to force you to do it. It's a really good habit to get into, is check your answer. Right? That solution needs to make both of your original equations true. If you're checking your answers and it only makes one of them true, it makes the other one false, you did something wrong, right? Go back, double check your work, and make sure you did it correctly. Alright? Any questions about solving by equivalent forms? Okay, please try the second one then, the one below the steps. You got it? You sure?
I can't even trust myself anymore. I actually don't.
Would I add one here, Conroy?
No, I meant to write that as a minus 2.
Okay. Alright. I got it.
Yeah.
Yes, that is me. I am that.
I meant to.
Shut up. Die.
Related to that one day closing services. She's like,
Hold on.
like that.
Hey,
Like,
good job, man.
if you
Actually,
correct
corrections
me,
are
correct me,
hard.
that's-
I can do it if I want to, but.
Oh, but I still want to.
I don't.
I don't.
Guy gets 1 on 100 and now look at him.
Is he okay?
I know. Alright guys, hey, how we feeling that? Good, so?
100% right now.
Alright, sweet. Can I keep going?
We take the test on this.
No. So, next page. Second way we're going to show you is by substitution, right? You should see this already. First step, guys, one of the equations, solve one of them for one of the variables. A lot of times this will be done for you. Right? Like I said, last one, the equivalent forms, it's both going to be equal to the same thing if we want to use that method. If we want to use substitution, one of your equations should probably be equal to one of the two variables, whether it's equal to y, equal to x, equal to whatever variable you're using. Step 2 then, substitute the expression for x or y, whichever one we had to solve for, or whichever one was given to us, into the other equation. Well, if I know that y is the same as 3x minus 5, right? I'm going to take 3x minus 5 and plug it in for y in the other equation. That way I'm essentially getting rid of a variable. I only have one left to solve for. So y is equal to 3x minus 5, so I'm going to take it and I'm going to plug it in. 2x plus 5 times 3x minus 5 equals negative 8. Step 3 then, solve the resulting equation for the first variable. Well, in this case our first variable is x, so let's solve for x. Distribute to 5. 2x plus 15x minus 25 equals negative 8. Combine your like terms, 17x minus 25 equals negative 8. Add 25. 17x equals 17. Then to solve for x, all you got to do, divide by 17.
Whoa. Oh, that's really difficult.
Just like 36 and a half.
X equals 1 or 0?
I don't care.
X equals 1. Alright, so,
I don't.
step 4. Substitute the solution from the previous step into either original equation. Solve for the second variable. Wick, do you want to use the top or bottom equation?
What?
Which of the original equation do you want to use?
Top.
Top. Alright, so y equals 3x minus 5. Hey guys, I would probably always use the one that's equal to the opposite variable already. So you have to do any solving afterwards then, right? It makes it easier. So let's use the top one. Plug in 1 for 3. Y equals 3 times 1 minus 5. Well, 3 times 1 is 3. Minus 5 is going to give me negative 2. So x is 1, y is negative 2. And what do you think that next step's going to be?
Or the order pair.
Write the solution as an ordered pair. 1, negative 2.
Can't do it, stats.
And then lastly, if you want, like I said, really good habit to do, check your answers in both equations. Plug in for x, plug in for y. Make sure they both come out to be true statements. Did I go too fast?
Can we just use one of the equations? Or do we actually just
Well, the problem is, Cole, some of your solutions might work in one of the equations, but not in the other. So if you're going to check it, you got to check it in both. Okay? Alright. If you're done with that one, you're good to move on. There's a problem on the next page. It's our last problem of the day. Please try it. Well, we're going to go through the test, then we'll have work done.
I don't need this.
I don't want to say this, honestly.
That's alright.
Yes, sir.
I'm so honestly being bored myself.
If I get this one right, let's make a bet. I'm pretty confident on that. Then you'll change I get to retake that one question.
Man.
You shave your beard.
What?
No, that's a good.
I don't remember last time
Hey.
I went clean shaven.
Hey, if I get a 100 on the final, you shave your beard. If I don't, I do the bell ringer for 2 months. That's
That's fair.
That's pretty good.
Wait, sorry, what's up?
If I get a 100 on the final, you have to shave your beard. And if I don't, I do the bell ringer for 2 months, second semester.
Deal.
Alright.
Shake up.
How about an A? Fine.
Alright. Guys, if you have an answer ready, please check your solution.
He's about to make one that's super difficult just so.
I would.
Dude, that's
I don't care. I made a bet with a girl, but she could shave my head if I lost the powder puff game.
Can I shave your